Hello students, welcome back. Let's take up the next question. So in this question, we have a combination of resistors as shown in the diagram, and we have to find out the equivalent resistance between M and N. So these 2 points are given M and N, and we have to find out the equivalent resistance. So though this circuit seems to be difficult, yet it's very easy. What we have to do is we have to understand that M and N are connected to the two ends of the battery, and if we stretch the wire at M and N, stretch it in the opposite direction, we'll have the circuit opened. And how will it look like? Let's start. So if this is point M, from point M we have the wire going and joining R1, resistor R1. So let us draw here R1. Then the other end of R1 is connected to R2. So here you see at this point there is no branching, only the wire has bent. So it is the same wire which is continuing, which means that R1 and R2 are in series with each other. So this is R2. Next, the other end of R2 is connected to this point. So here let us assume this point X. So at the point X, the wire is branched now, because you see here, while the other end of R2 is coming, and at this point there is only bending, there is no branching. So this is a single wire which is coming, and at X only it is branching into R3 and R4. So let us assume this is point X, and here is R3 and R4, and this is point N. This is R3 and this is R4. Now it is easy. This diagram is easily understood. So now let us solve it first. How will we solve? First we have to solve this branched part. Okay, so this branched part will solve, and then we see that whatever the equivalent resistance of this parallel circuit comes out, it will be in series with R2 and R1. So we'll find out that later on. But first let us solve the parallel part. So we know that for parallel connection, the formula is given by 1 by Rp is 1 by R1 plus 1 by R2 and so on. So here let us find out what is Rp. Instead of R1, here we have R3. So 1 by R3 plus 1 by R4. So the LCM is R3, R4. So here it will be R4 plus R3, which is equal to R3 plus R4 by R3, R4. So 1 by Rp is this much. So Rp will be R3, R4 by R3 plus R4. So this is our equivalent resistance of the branched part, that is the parallel part, R3 and R4. Now this equivalent resistance is in series with R1 and R2. So now in order to get the final resistance of the circuit, we'll have to solve it for the series resistance. So RS, resistance in series, is given by R1 plus R2 plus and so on. So here RS will be R1, this one, plus R2, this one, plus this equivalent circuit Rp. So Rp. So what is the value of Rp? We'll substitute the value of Rp in this equation. So it will be R1 plus R2 plus R3, R4 by R3 plus R4. So this is our final answer. The equivalent resistance of the resistance between M and N. So simple. I hope you have understood this. Just remember, wherever you get the endings of the circuit, just stretch it in opposite direction in both the ways. Just stretch it open and you'll have a easier circuit diagram in front of you which you can solve easily. I hope you have understood. If you have any other questions similar to this, please ask in the comment box. I'll be happy to answer you. Thanks.